2,844 minimum operations to make a special number. 2844 minimum operations to make a special number. This is certainly a cool problem. And why do I think it's cool? I think it's cool because I could easily solve it, right? If something is easy for me, then I tend to conclude that it's fair. And if something's difficult for me, then I tend to conclude that it's unfair. It's kind of coincidental how that really works. But anyways, let's go ahead and get right into this. This is a fun problem. Okay, you are given a 0 index string num representing a non-negative integer. So it's a string representation of an integer, right? What does that mean really quickly? Well, you could have x being like 1, 2, 3, 4, right? Or you could have a string representation of the integer, which means you have those quotes around it, right? 1, 2, 3, 4. And what's the difference between these two things? Well, this is treated directly like a number. So if I add 5 to this, I get 1, 2, 3, 9. And I move my head out of the way. But if I add 5 to this, well, it's kind of undefined. It depends on the language specific. But usually that results in 1, 2, 3, 4, 5. Right, because I'm just going to append the 5 to the end because it's just a string, right? The beautiful thing about dealing with strings is if we have x like this, I'll call it x bar actually, I could do x at 0, which equals 1, right? Because I can index in it, I can take things out of it, versus this just 1, 2, 3, 4 standard as it is. If I try to say, what's x at 0, it's going to error because it's not an array, it's a number, right? So it's treated as a number versus just like a string of characters like an array. Kind of a relevant point, but it's never a bad idea to just kind of conceptualize what you're actually looking at so you can understand what you need to deal with. In one operation, you can pick any digit of num and delete it. Note that if you delete all the digits of num becomes 0, okay? Return the minimum. So what does it mean to delete a digit in here? Right, so if I have x equals 1, 2, 3, 4, 5. Deleting a digit, like say I want to delete, I don't know, the second digit. Now, what does it mean second? Well, that's always an issue with arrays, right? Because it starts at 0. So let's say that, these are our digits here. So there's a 0. Kind of gets confusing when you do it like this, right? So this is the 0 digit. So if I want to delete the 0 thing, then it becomes, right? If I delete the 0 thing, it becomes 2, 3, 4, 5. So when I'm deleting the 0 thing, I'm just deleting the 0 thing, right? If I want to delete the second thing, right, I delete that 3. So if I want to delete, I don't know, 3, I get 2, 4, 5. But of course, well, I said this 3 and 0. Ugh. To be consistent here, this would be 2. It doesn't really matter, right? Because I'm just trying to get the point across. If some of these standards don't really make sense, it's not important. The point part here is, right, I can delete characters out of this string, right, which is equivalent to deleting one of the digits out of the number. Okay, return the minimum number of operations required to make num special. Okay, so I'm gonna delete out things in order to make this number that I'm provided special. Okay, so then that begs the question, right? What does it mean for a number to be special? Well, in order for a number to be special, an integer x, it has to be divisible by 25. Okay, so this is one of those problems where you have to have at least some understanding of I don't know if I call them discrete math concepts, but this is certainly something I learned in discrete math. What does it mean for a number to be divisible by 25? Well, for something to be divisible by something else, all that means is that the remainder is 0. Like it goes into it wholly, okay? And I guess the best way to explain it is like 25 is divisible by 5. That's a remainder because the remainder equals 0. And if you think of that conceptually, it's like 25 divided by 5 is 5. I keep doing bad examples here. Let's say 30. 30 is divisible by 5 because 30 mod 5 equals 0. Because 30, how many times does 5 go into 30? 6, right? So 30 divided by 5 is 6. It's a whole number, right? But what is 30? And it feels good. It feels natural. When you divide something by a whole thing and it ends up being a whole number, it feels natural. But what about if I say, what's 30 mod 7? So what's 30 divided by 7? You think about that and you just go, ugh. Ugh, I don't like that at all. Why? Because 30 divided by 7, it's like, well, 7 goes into 21, 21 plus 7, 28. So that's 7 times 4, 28. But then it doesn't go into 30. Right? So 7 doesn't go into 30, so it doesn't feel natural, right? So when something's divisible, it's those natural whole number divisions, right? When I divide this thing out, I get a whole number. I don't get some weird parts thing, right? So x is special if it's divisible by 25. So what that means is when I divide this number x by 25, the remainder is 0. Okay? So what are those answers? Well, like let's just think about a sum. All right, what's 50? 50 divided by 25 is 2, so it's a whole number. So 50 is divisible by 25. It equals 0 when you do the remainder. What else? Well, you can just think about it. You know, you could go through every single number, or you could think, well, it's the same thing as the multiples, right? 30 divided by 5 equals 6 because 6 times 5 is 30. Right? Or I could just think, okay, what's divisible by 5? Well, 5 is, 10 is, 15 is, 20, 25, 30, 35, 40, 45, 50, all the way up into infinity using that pattern going forward. Right. Okay? So when you think about 25, well, 25 is going to be an answer. 50, 75, 100, 125, 150, And also technically, this is always one that gets people, 0 is technically an answer too, right? Because 0 divided by 25 is what? 0. So that's a whole number, right? Because what we want is we want to make, for something to be divisible, when you divide it, there's a whole number. And that's 0, and 0 is a whole number, so it still works, even though it's kind of weird. It's like, well, yeah, kind of like technically, this is one of those like technicalities of math, right? 0 is a weird number, right? 0 will really trip you out sometimes. Okay, so 0, 25, 50, 75, 100, 125, 150, 175, 200, 225, 250. I could be here to the end of time telling you about, you know, numbers that are divisible by 25, right? But that's kind of the pattern, right? Okay, and I could, you know, say this formula in a very formula language. Well, for to be divisible by 25 is 25x, you know, for all x and the integers. Yes, and we'll call it the non-negative integers or whatever that is. Yes, but you know, this is basically what that means here, right? 25, 0, 25, 50, 75, 100, 125, 150, all the way until the end of time. Okay, so what we want to do, just to make this clear, is because we kind of went on a sidetrack to figure out what it means for something to be divisible, is we want to take that initial number that we're given and we want to remove something from it so that the resulting number fits into this pattern so that it's divisible by 25. Okay, so let's go ahead and get right into the example. Okay, so in our example, our num is given as a string. Remember a string and how its relationship works between things. We got 2, 2, 4, 5, 0, 4, 7. All right. Now, we have to make this divisible by 25. Now, the output is 2. The output of 2 is because that says you're going to delete 2 digits to make this work. And the 2 digits you're going to end up deleting are this one and this one. And why is that? Well, because the resulting number would then be 22450. And this mod 25, the remainder would be 0, right? Because you see this 50 here, right? You might say, well, that's a huge number. I'm going to have to go through this thing forever, right? I'm going to have to go 150, 200, 225, 250, 275, 300, 350, all the way up into, you know, what is this, 22,450 to realize that it's divisible by 25. But there's a little bit of a trick here, right? And that trick will become clear in a second. But yeah, this is divisible by 25. Just trust me. Maybe you already see the pattern. But right, this is divisible by 25. It equals 0. So if you just delete these 2, 4, and 7, you get this ending up. You get this number as your result. You mod that by 25, you get 0. You take the remainder of that, you get 0. You divide it by 25, you get a whole number. So that's why that is the answer. All right, what about number 2? All right, let's look at another example. Maybe that will help you, it will lead you to some sort of conclusion about what the pattern is here, what we need to do to make this work. 2908, 305. All right, I'm not going to look at it. Let's see. Well, I know you could do this, actually. So if you delete this 8, this 3, and this 5, you get 2900. And if you mod that by 25, you get 0. So that would be an answer. So if you delete 3 things. Now this is saying delete nums 3. So 0, 1, 2, 3. So the 8. Delete nums 4. 0, 1, 2, 3, 4. So that's the 3. And then delete nums 6. That's the 5. Okay. So how did I figure that out so quickly? Well, although this pattern is like 0, 25, 50, 75, 100, 125, 150, let's just go through a few of them, okay? And I'm going to write it in a kind of weird way. And I'm going to say, okay, the first number in my pattern is 0. The next thing that's divisible is 25. The next thing is divisible is 75, then 100, then 125, then 150, then 175, 200, 225, 250, 275, 300, 325, 350, 375, 400. So we're looking at this and saying like, okay, why am I doing this? What's the point again? Well, I'm trying to figure out, what did I do here to figure out what it was so quickly, right? And what did I do up there to figure, well, you know, when something's divisible by 25, you'll notice that the same thing keeps happening again, right? I see this 0, 0, then a 0, 0, then a 0, 0, right? I see this 25, then a 25, then a 25. I'm running out of colors here. I see this 75. I see this 75. I see this 75. I skipped over a bunch of zeros. You see what's going on here? Do you get what I'm trying to put down here? Right? The point is that the same thing keeps happening over and over again. And whatever happens over here, right, to the left side, all these numbers, it could go on forever, right? Imagine these were all numbers, right? This is X, Y, Z, A, I don't know, A, B, C, D. Whatever these numbers are is irrelevant. Right? Everything here is irrelevant. And why is that the case? Well, because for it to be divisible by 25, all we need to do is look at the last two numbers, right? These last two numbers are all what contribute to this being divisible by 25, right? So when I looked at this example, all I was looking for was a 0, 0 pattern, right? I was like, okay, how do I get a 0, 0 pattern in here? Right? What's the minimum number of operations to delete to get a 0, 0 pattern? What's the minimum number of operations to get a, look, I skipped 50 here. Apparently I can't do the simplest of math. But look at this. This is what's so beautiful about having a tablet, you know? You can make simple mistakes and you're still saved. Right, so the point is here, right, is that whatever these numbers are to the left are irrelevant. It's just these last ones. So when I saw this 0, 0, I thought, okay, I can make it 0, 0 here. What's another way you could do it? Well, you see 25, you could do 25 here, so you can delete everything in between. Right, so it's a little bit clear about what you can do to make this divisible. Right, this nums here where I see a beautiful looking 50 I did red. Right, I see a 50 right here. Maybe I shouldn't have done red. I see a 50 right here. So if I delete the 4 and the 7, the last two numbers are 50, and then I'll be good. Whatever's to the left doesn't matter. Right? The same here. Right? If I make the last two numbers 0, 0, then whatever's to the left doesn't matter. Okay? So that's the general idea about, you know, solving this problem. But all I need to do is think about the last two digits, because that's the only thing that's going to matter when it's divisible by 25. Everything to the left is irrelevant because it just ends up being the same pattern over and over again. 0, 25, 50, 75, 0, 25, 50, 75, 0, 25, 50, 75. All the way to the end of time. Okay, so my goal here really is one simple thing. My goal is to make last two digits either 0, 0, 25, 50, or 75. That's it. Right, so I've just greatly decreased, right? Because right before we were thinking about all the infinite number of numbers of things that are divisible by 25. But now it's really just, it's just 0, 25, 50, 75. That's it. We don't need to think about anything else. As long as we can make the last two digits, right? We can make the last two either 0, 25, 50, or 75. We'll be good to go. Okay. So how are we going to do that? Well, there's a couple tricks we can use to try to do this efficiently. Okay. If we have a number, right? Should I do a general case or should I do an example? Let's do a general case, right? If I have a number, let's say that it's I'm just going to put Y's here to represent that there's things in the way. All right. And then let's see, I see a 5. And then a bunch of other Y's. Y1, Y2, Y3. What I'm trying to do here is I'm just trying to say, you know, let's just say I don't know what the Y values are. All I know is what the, there's a 5 right here. Okay. What would it take to make this thing divisible by 25? Well, let's just think about this example alone right now, and then maybe we'll do it for each one. Okay. How would I make this number divisible by 25? Well, I want to make the last two either 0, 0, 25, 50, or 75. So there's a couple ways I can think of. Let's say that well, there's, you can do double directional. Sorry, sometimes when you're programming, right, your brain will go off on these tangents because you'll think about all of the possible things that could happen, and then it starts branching out. So I'm trying to confine this so I can explain it to you simply. But basically, let's say that this is the last number. It's a 5, right? So let's say this was the last number that was a 5. We wanted to make this the last number that was a 5. So in order to make this work, right, I'm going to have to delete all of these. And I'm going to have to find the 2 that's in here. Right? So for example, if we had it like this, let's say I knew that there was a 2 right here. Let's move this over. Ooh. Getting complicated around here. All right, and let's say there's just more y zeros, y negative 1, I don't know, y negative 2. Right? In order to make this work, I have to find the 2 in here. Right? So I'll have to delete these last characters. I'll have to delete these characters, and that's it. Right? I don't need to delete these ones because these are to the left. Right? So to make this work, I would have to delete the things in between. Apparently, I didn't make my X big enough. Ugh. Sorry, guys. Amateur hour here. I have to delete these 3 Y's. I delete everything at the end, and then I just leave these things in between. Because what does this end up resulting in? And even if this goes on forever like this, right? This results in y negative 2, y negative 1, y 0, 2, 5. Okay. No, so I could find a 2, or I could find a 7, actually. Right? Because it could be a 75 at the end, or a 25 at the end. Okay. Let's think about another case now. What if it was a 0 here instead? Or if it was a 0 here, I would need to find the last 0, right? Because that's the only thing that can go with a 0 at the end to make it divisible by 25. So let's say right here was the last 0. And that would result in an answer of 0, 0, 0. Okay, so in order to make this work is if I have a 5, right, I can match it up with the closest 2 or the closest 7. I have to delete everything in between the 2 and the 7, the 2 or the 7 and the 5, and I have to delete everything after. Same thing with 0, right? I find the closest 0, I delete everything in between, I delete everything after, and that would be the shortest thing I can create using this system, right? So to make the last 2 things either 0 or 5, I'm going to move all this over because I kind of want to keep this on one nice little docket for you guys. Right? So the goal is to make the last 2 digits either 0, 25, 50, or 75. What I can do is find the last digit. So I find the last digit. I delete everything after. I delete everything after, and I delete everything in between. Second to last digit, and last. All right, this is terrible explanation, but what I'm basically saying is I find the last digit, and then I find what would match with it. So this 0, the only thing it can match with is 0. So I delete everything after, and I delete everything in between this 0 and the last 0. Right, for 5, I delete everything after, I delete everything in between 5 and the thing that it could attach to, either 2 or 7, to make this thing 25. And of course, if there was a closer 7 here, right, if there was a 7 right here, for example, if there was a 7 here, well then obviously I would want to just attach to the 7 because it's closer and only delete one thing to make it 75, right? So that's kind of the idea about how this is going to work. So what we can do to make this work at a very rudimentary way is look at all the digits and then try to find the closest member to you that you can delete. So what is the recurrence relationship of this? not recurrence relationship, but how would you do this? So, always getting into code is the non-fun part of this, right? Let's move this over here. Let's actually just make this, oh, I can't do that here. I'm gonna move that off the screen. And we're gonna think about what the recurrence relationship is here. So let's look at this example. Again, with a fresh new set of eyes about, because now we know some things about the nature of this problem. All right, 5, 0, 4, 7. Okay, and then what we're gonna do is we're gonna start with our index equaling 0, 1, 2, 3, 4, 5, 6. And then also, just to note, is know that the length of this array is 1, 2, 3, 4, 5, 6, 7. So the length of nums equals 7. All right, just to note that. Now, what are we going to do to make this work? Okay, let's actually label this as nums equals this, just so it's a little bit more, I guess not an array. Strings are just arrays of characters, right? So it is an array, depends on how you want to look at it. Okay, so what are we going to do now? Well, we know the answer is 2, right? Because we're going to have this 50 at the end. But how would you programmatically look through that? Well, what you can do is you can say, well, okay, I'll look at this 2, and I'll say, okay, there's no options where 2 is the last number, so just disregard it. I look at this 2, I'm like, there's no way I can make 2 the last number, so disregard it. I look at this 4, and I say, there's no way to make 4 this last number, so I'll disregard it. Now, when I look at 5, well, there's 2 ways to make 5 the last number. Either 25 or 75. So I say, okay, if I want to make 5 the last number, how long is that going to take? Well, I'd have to delete everything in between 5 and the closest 2. So I'm going to get plus 1 for that. I'm going to get plus 1 for the, I'll write it down, right? So I'll get plus 1 for that, right? To delete this 4. Right, to delete this 4, I'll get plus 1 for that. And then I'm going to get plus 3 because I'll have to delete everything that comes after. So that's going to be 4 operations to make that work. Now, I don't want to shred these. Okay, what about 0? Well, if I want 0 to be the last number, it's either 0, 0. Oh, I made a mistake earlier because I said the only thing before 0 is 0, but no, it could be 52. So the only thing before 0 can be 5 or 0. So if I want to make my last number 0, well, the closest thing I can attach to is this 5. So that's going to be plus 0 for that. Right, and then I'm going to have to delete everything that comes after. So that's plus 2. So that gives me a 2. So that's probably a good option. 4, there's nothing for that. 7, there's nothing for that. So my answer here would be 2, because the best thing I could do is attach the 0 as the last number, attach it to a 5, and delete everything that comes after it. Okay, so the relationship here is, well, if I have an I, right, so I have to delete everything between I and the last time I saw the match of num at I. So this is getting a little bit complicated here, this relationship, right? But basically, I take I as the index, right? I look at the num at I, right, which is 0, and I say, what's the match for 0? The match for 0 is 5, right? And when's the last time I've seen a 5? Well, that's at 0, 1, 2, 3. That's at 3, right? So if index is 4, 3, how many do I have to delete in between? I delete 0 in between, so I subtract 1 from that. Okay, so let's just walk through this reoccurrence relationship to see. So this is how many I delete to the left, right? That's this top part, right? So let's look at it from the example of this, right? So here I is 3, right? I is 3 here. And I'm going to subtract the last time I saw the match for nums of I. So let's walk through this one at a time. Minus 1. So what's the match for... So what's nums of I first? Let's just do this one step at a time. Nums of I at 3 is 5. So that's 5. Okay. What's the match for 5? What matches with 5? Either 2 or 7. Now I know the answer is 2 here, right? So the match for 5 would be 2. It could be 2 or 7, and we'll capture that. What's the last time I saw a 2? The last time I saw a 2 is at index 0, 1, 2. Okay. And what's 3 minus 2 minus 1? 3 minus 2 is 1, minus 1 is 0. So this should be, see, that's why you walk through these equations, right? So this should be plus 1, not minus 1. Plus 1, plus 1, plus 1, plus 1. And that equals 1. So this is a way to kind of capture the formula for the things you have to delete, right? Because I have I, that's the index I'm at, right? Then the amount I have to delete is the space between I, because this is going to be the last number, and the amount of characters in between, which is the distance to the number that I'll attach to, right? So what I basically say is, okay, here's the equation for index I. What's the number at index I? That's 5, right? What's the match for 5? Well, that's 2. When's the last time I saw 2? That's at index 0, 1. Guys, I'm losing it here. 0, 1. Last time I saw 2 is at index 1. Okay. Walk through it again. When's the last time I saw 5? No, wait, what's the match for 5? 2. When's the last time I saw 2? The last time I saw 2 is at index 1. So 3 minus 1 equals 2, so then it is minus 1. Oh, gosh, guys. So minus 1 plus 1, always difficult. The idea of, you know, trying to deal with 0 is always difficult. These are common programming issues, right? Off 1 errors, dealing with 0. Okay. So that's the equation here. Right, and then we could do it again for here, and I won't go walk through the whole thing, but you'll see, right, for 0, or, okay, for I equals 4. How do we get this top number? I equals 4, so that'd be 4 here. So 4 minus the LM of nums of I. What's nums of I? Nums of I is 0. What's the match for 0? That's 5. When's the last time we've seen 5? That's at 3. So 4 minus 3 is 1, minus 1 equals 0. All right, then how do we get this number to the right? Well, that's just what comes after, which would be, simply put, well, that would be the length of nums, right? Because that's how many you have to delete. Minus I, minus 1, right? So the length of nums is 7, right? 7. So here, I have to delete 2. My index is 4, so 7 minus 4 is 3. That's 1 too big, so I minus another 1. So I do length of nums minus I minus 1. Right, so my full equation would then be I minus the last time I saw the match for nums of I. I'm going to make this clean. Make this clean, man. I'm really trying for you guys here. Just not a very good writer. All right, I'm going to make this super clean. It's going to blow your mind. All right, so equation is I minus the last of modified of nums of I minus 1 plus the length of nums minus I minus 1. So first thing you notice is that these i's cancel, right? So these i's go away, right? Because you get I, minus 1, minus 2. So then it's just the length of nums, I'm going to reorder here, minus L of M of nums of I minus 2. So that's the equation here to find it, right? So all we basically do to make this work is we say, all right, for this number, what's my match? When's the last time I've seen that match? Delete everything in between that match and me, so I can make these the two last numbers, and then delete everything after, and that's where the length of nums part comes in. But of course, you know, when you combine things, sometimes things get eliminated, right? So even though there were two separate ideas, it looks like something totally different when you combine them together, and that's the beauty of math, right? Sometimes, you know, you take 1,000, then you subtract 1,000, you get 0. You end up with 0. You're like, how did I get here? I don't know. But really, you took 1,000, you subtract 1,000. That's how much my bank account every week. No, I'm joking. Okay. So what we need to do then is somehow capture these L and M ideas. And I'm going to do that completely in code because I've really exhausted, I think, everyone's attention span at this point. If you're still listening, right? If you're still watching this video, drop a comment saying, I'm listening. And there will be an award. I will reward you if you drop a comment right now and say, I am listening. Just so I know you're here. It takes a second. Or you don't even say I'm listening. Just type like that. Just type. Seriously, like just randomly type characters and hit enter. That way I know you're real. And that way other people won't look at the comments and not watch the video and then know what they're supposed to do, right? So this is our little secret between me and you. Just type it in the comments and people will be very confused. Okay, so what are the ideas here that we need to get across? So we had this last idea, right? I'm gonna make that a default dict. And I'm gonna make the default value float negative infinity to specify that, because what we don't want is we don't want to say like, what do we do when the last time we saw something is like we've never seen it? Well, we'll say that's infinitely far away. Okay. Hopefully that makes a little bit of sense. Maybe make more sense when I actually solve this problem. And then the matches. What are the matches for all the numbers? Well, let's say that the matches for something that doesn't exist, right? Because some numbers don't have matches, like 4, right? Like we skipped right over 4 because 4 didn't have a match. Right? There's nothing you can match 4 with to make this work. 4 is never going to be the last digit because there is no divisibility by 25 with 4 as the last digit or as any digit, right? So what are our pairs that have matches? Well, the matches for 5 are what? Well, I can put 2 or I can put 5. Now notice I'm not just putting 2 or 5 alone because we're dealing with strings here. So we're going to try to keep everything as a string. What are our matches for 0? If 0 is the last number, then it could either be, not 55, this is 7, right? It could be 75 or 25. Our matches for 0 are 0 or 50, right? So this is, if my last number is 50, my last digit is 5, then my match is 75 or 25. If my last number is 0, my match is 50, so 50 or 000, right? 100, 200, 300, 400, 500, 600, 700, 800. All right, so on and so forth. All right. Now there's a little edge case that I don't know if I want to put that in here just yet. Maybe what I'm going to do is I'm going to submit it. You're going to see the error. And then from that edge case, you'll realize, oh, there's a little condition we need to think about because it's not super intuitive. Okay, so what are we going to do to make this work? Well, we're going to look at each I in the range length of num, just like we did in the other thing. And then we're going to try to find matches, right? So we're going to say, well, let's say res is our solution to begin with because we want to find what our solution is. And we'll say float negative infinity. And at the end, we'll return res. Right, so this is going to be what I'm updating to try to look through and see, okay, what's my best option here? Right now, what I'm going to say is, okay, for all my matches, so I'm going to call those, so our second digit, so we're going to have a first digit and a second digit. That's for our first and last digit, right? So like XA, I don't like using that. Let's say YYFS, right? So this is the first last digit and the second last digit. All right, so first, let's just call it XY. Okay, so Y would be nums of I. So that'd be the last digit. All right, and then what are all of our matches? So for X in matches of Y, right? So what we're gonna do is we're gonna say, well, res, if we have a match, how are we gonna make this match work? Well, it's just the formula, right? So it's res equals what? So we did the equation. I have it written down here. Remember, it was length of nums minus the last time that we saw m nums of I. Well, this is y is nums of I. Right? If I really wanted to do this like a crazy person, I could say, when's the last time I've seen, you know, the match of nums of I? Right? That's what it looked like on the paper, but nums of I, that's just y. Right? And then I just did m's of y, x for m's of y, so this m's of y just becomes x, right? And then it was minus 2. So, but that doesn't mean that the new thing we're looking at may not be the best one, right? So we want the minimum. Whatever we think the best thing is, so res should be infinity, sorry, this is negative infinity, right? Whatever we think the best is, and whatever we can get now using this, and we can do that for every single number. All right. Okay. And now what I'm going to do is, well, this is kind of the tricky part here, right? Because how do we know the last time we've seen a number, right? We never really walked through that. Well, the last time I've seen y is right now. Right, so when I go through this, I should just keep track of the last time I've seen everything. Right? When's the last time I've seen 5? When's the last time I've seen 2? I keep track of that in this little dictionary ledger. Right? I keep track of, okay, when's the last time I've seen this? When's the last time I've seen this? And I update it through. That way, as I go through, I always have access to the last time I've seen the match that I'm looking for. Right? So that's pretty much it. The name nums is not, I keep doing that. It's num. It's always nums, but for some reason it's not, okay, it's not a set of nums, it's just nums again. I did it again here. Did you mean num? It's kind of cool that the interpreter knows that I'm an idiot, you know? It's like, that's not what you meant, dude. We all know that's not what you meant. All right, so let's submit this. It's going to be wrong, so let's start thinking about the edge cases here. All right. Infinite is not a valid for the expected return type. Okay. Now this 0, this 10 is an interesting example because, well, what happens with this 10 is, well, if you delete this 1, it becomes 0, but you don't have a 0 to match it with, right? Because really 10 is like this. Like 10 is actually this, technically you could think of it like this, right? So the first 0 I can match 10 with is this 0 before and it becomes 0, 0, right? That simple trivial case we talked about in the beginning of 0, 0 by itself. So technically the last time we've seen 0 is -1. Right? Before any of these numbers started, there's an implicit 0 at the beginning. 0, I told you, always being one off, and the reality of 0 is always what messes you up in math and computer science. Right? So the last time we've seen 0 is actually before this, right? Because this is my my number initially, right? But technically I could put a 0 right here. Right? So this 0 could match with this 0 over here if we wanted to. Okay. So that will take care of that first thing, right? Because this 0 has nothing to match with, so it thinks it's infinity. Now, the other thing is, well, when you have just 1 by itself, well, technically, 1 by itself, you can't match 1 with anything. But 1 is actually 0, 0. You can think of it like that. So I could remove this 1, and then I just have 0, 0 left. So if I have a bunch of digits like this, right? Even if it never works, I can delete all the digits and get just 0, 0 by itself. So I'll return res if res does not float infinity, meaning that I found a solution using the numbers that were provided. Otherwise, I can't get a solution if res is float infinity, and I'm just going to return the length of nums, because that means I have to delete everything to make this work. Length of num. Oh, dude. See, that didn't happen. So that's a fun thing about Python, right? Is it didn't error out because it never reached this statement here. It didn't read the whole thing. It just interpreted it as it went. So you could have errors in your code if untested will end up in production. Something interesting to think about. Okay, so what is the run and space complexity of this problem? Okay, so let's say n is the length of num. Right now it's weird because num is a number, so what's the length of a number? But no, it's really just a string that we're dealing with here, right? A string with some implications about divisibility. Right, so n is the length of num. For space, it's a little tricky, because you're saying, well, we create these two arrays, and these two arrays get updated, right? They get updated throughout the whole array. So doesn't that grow proportionally with the number of elements? Well, no, because this array will never have anything more than 0 through 9, right? Because I'm always only looking at numbers, and I'm only looking at the last digits, and the digits can only be 0 through 9, at least in a base 10 system that we use, right? So it doesn't matter how large the array is and how many times I update M or I update L, right? Like the last time I've seen 0, it's only going to get updated with the last time that I've seen it, right? But it will never be more, there'll never be more than 10 elements in L, because I'm only going to keep track of the 10 digits that I can look at. So regardless of how large the thing is, I'm only going to keep track of the last time I've seen any of those 10 digits. So that's constant space. I know it's a little weird to think about, but yes, it is constant space because I'm only looking at these 10 digits. I never look at anything else. All right, what about for time? Okay, for time, well, I create these two arrays. It's constant. I keep this. I look at all the numbers. So I look at all n digits in the num, and then I look at all their matches. There's only ever at most 2 matches. So even though there's another for loop here, I'm only looking at 2 things. So that's n things. I do something constant. I do 2 things. I do a little calculation, constant. It's all constant. So that's big O of some constant times n, or that's big O of n. And then here I just do a constant operation. So that's big O of n. All right, guys, that's it for today. I hope you learned something. Peace out.